Hello, I am Pujani. Today I'll walk you through our machine learning project where we predict whether bank customers will subscribe to term deposits. We are comparing four supervised learning algorithms to find the best model for this classification problem. So if we look at the problem, first let's understand banks spend significant resources on marketing campaigns to convince customers to subscribe to term deposits. They need to identify which customers are most likely to say yes so they can target their marketing efforts effectively. This is a binary classification problem. Our goal is to predict yes or no for each customer. Let's look at the dataset. The dataset comes from the UCI machine learning repository. It contains information about 4,521 bank customers with 16 original features, including demographics like age and job, and financial information like account balance, and campaign details like contact duration, frequency, and prior outcome. So the target variable is simply yes or no for subscription. So this is the URL. This is where we downloaded our dataset. It has a summary of the dataset here, including the variable tables. Let's look at the algorithms that we selected. So we selected four algorithms. The first one is a logistic regression, which is a linear baseline model. The second algorithm is the k-nearest neighbors, which is a distance-based classification algorithm. The third algorithm is the support vector machine, which is a nonlinear kernel classifier. And algorithm 4 is the random forest, the ensemble voting method. Now let's look at how we implemented this.
Now I will explain the data pre-processing and the visualization part. Firstly, I import the request libraries, the basic libraries pandas and numpy for data handling, matplotlib and seaborn for the visualization part, and then I upload the data set. After that, I explore the dataset using these functions: the head function for show the first 5 rows, the shape function for the rows and columns count, the info for data, check the data types and null values. This function for check the machine values of the data sets. Next, I analyze the target variables, age distribution, job distribution, and the balance distribution, and subscription based on job. Target variable distribution, age distribution, and the job distribution, balance distribution. Now I also check the relationship between job and the subscription. That is the visualized part. And check the outliers. Next, I detect the outliers using box plot, the age, balance, and duration. The age, balance, duration. Then I remove the outliers from the balance using IQR model. I calculate the Q1, Q3, and IQR. Then remove the extreme values. For duration, I don't remove the data. Instead, I clip the values 95 percentile. After I cleaning, I visualize again the using box plot the confirmation improvement. These are the visualization part. Finally, I prepare the data for machine learning. Firstly, I convert the target variable yes for 1, no for 0. Then I apply one hot coding using So overall, this pre-processing step help to clean, transform, and prepare the data for model performance. Thank you.
My name is Poojani, and I will show you how I implemented the K-nearest neighbors algorithm for the bank customer subscription prediction task. The goal is to predict whether a customer will subscribe to a long-term deposit using the pre-processed dataset. In the first cell, I imported the required Python libraries, and I have used a train test split to divide the dataset, and K-neighbor classifier to build the model, and evaluation functions such as an accuracy score, classification report, and confusion metrics to measure model performance. So in the next cell, I have loaded the preprocessed dataset from the CSV file, and in here I separated the dataset into features and target variables. So X contains all of the predictor variables, while Y contains the output that we want to predict. So this is the key step of training any supervised machine learning model. So in the next cell, I have split the dataset into the training and testing sets. I used 80% of the data for training and 20% for testing. And in the next cell, I created a standard scale object. The purpose of scaling is to standardize numerical features. Since KNN depends on distance, scaling is very important. So in the next cell, I have created 3 KNN models with different values of K, which is the number of nearest neighbors considered during classification. And I selected 3, 5, 7 as candidate values to compare model behavior. In this cell, I trained the KNN model with K5, which I selected as the candidate model. The model learns from the training data by storing training instances. So after training, I use the model to predict the target values for the test dataset. The output contains the predicted class labels, meaning whether each customer is predicted to subscribe or not. In this cell, I displayed the test feature set and predicted values, then calculated the accuracy. This gave us a basic understanding of how well the KNN model performed on the data. And in the next cell, I have generated the classification report. This report provides a precision, recall, F1 score, and support for each class. These matrices are informative for us to understand how well the model performed in our data set. And in the confusion matrix, this shows the true negatives, false positive, false negatives, and the true positive. They show exactly how the model makes mistake, especially whether it misses actual subscribers incorrectly. And in the next cell, I performed a simple hyperparameter tuning for KNN. I tested K values from 1 to 10, and I printed the accuracy for each one. This allowed me to identify which value of K produced the best result on the test set. So in this cell, I imported MATLAB for visualization and additional matrices functions such as precision, recall, and F1 score. So in this, I calculated the performance matrices for my KNN model. So I added the already obtained matrices value for logistic regression, SVM, and random forest from their respective notebooks. So this made it possible to compare all of the 4 algorithms. So this is the result of the four algorithm based on accuracy, recall, precision, and F1 score. So this is how KNN performed compared to other algorithm that we chose for our data set. As you can see, KNN performed moderately, and if you look at the recall, KNN has a lower score compared to other 3 algorithms. So this is how I implemented the KNN algorithm. And now let's see how we implemented the other 3 supervised learning algorithms.
I'm Ranasinghe RAD. In this part, I implement the support text-to-machine SVM algorithm to predict the whether a customer will subscribe bank term deposit. Now I will show original data set. This is original data set. The target variable is y, which indicates the customer subscribe or not, yes and no. This is a pre-processed data set. The categorical value has been converted to numerical format and the data has been cleaned. And this is import our pre-processed data set and display the first five rows. The dataset was divided into input feature and target variable. Target variable is y. The data was split into training and testing dataset. This is the feature scaling was applied using the standard scaler. This is important for SVM models. SVM models are sensitive to scale of the input feature. I created three models for different parameters. I used the RBF kernel and C and gamma parameters control for the model behaviors. The second model is give a most accurate model. The model testing part. This is a prediction section. We already divided into training and testing data. That section used to testing data for model input. That model accuracy score is displaying the 90%, but that model predict the false values. That means that the model struggle with predicting the yes. We can get a more accuracy that model using the data balancing technique. Thank you.
Hello, I am Dhananjana. In our assignment, we developed a machine learning model to predict whether a bank customer will subscribe to term deposit. In my part, I implement the logistic regression algorithm. So now I will explain step by step. So first, I import the required libraries. I used pandas to handle the dataset. Then I import the train test split to divide the data. I used logistic regression to build the model, and I import evaluation metrics like accuracy score, classification report, confusion metrics. Here I load the pre-processed dataset using pandas. This dataset is already clean and pre-prepared for model learning. In this step, I display the first few rows using head to understand the data. I also check the column names to identify all available features. So here I separate the dataset into input features and the target variable. So X contains all input features, Y contains the target column, which is the prediction output. So in this step, I split the dataset into training and test sets. I used 80% of the data for training and 20% for testing. This helps evaluate the model on unseen data. So here I apply feature scaling using standard scaler. This step is important because logistic regression performs better when features are on the same scale. I fit the scalar on training data and then transform both training and testing data. So in this step, I create the logistic regression model. I used parameters like c equals 1 and solver as IBFGS and increase max iteration to ensure proper training. These parameters helps control the model performance. So in here, I trained the model using the training dataset. I use the fit function to allow the model to learn patterns from the data. So in this step, I use the train model to make prediction on the test dataset. The model predicts whether the customer will subscribe or not. So in here, I calculate accuracy score. So in this step, I generate a classification report. It includes precision, recall, and F1 score. These metrics give a better understanding of model performance. So in here, I display the confusion matrix. It shows how many predictions are.
Hello, I am Sangadeep WDI. That's a random forest model. The random forest model is used for multiple decision trees. It gives good accuracy and reduce the overfitting. In that my code, I import the main libraries, the pandas, sklearning. After that, I load the preprocessed dataset from CSV. Then I separate the dataset into two parts. Input feature X and the target variable Y. The target variable represents whether the customer subscribed or not. Basically, customer say yes or no. After that, I split the dataset into training datasets and testing datasets. Training dataset used for train the model. The testing dataset used for evaluate the model. Next, I create the random forest model with 100 decision trees, and I train it using the training data. Then I use the training model to make the prediction on the test data. Finally, I evaluate the model using three methods: the accuracy, classification report, and the confusion matrix. That's accuracy 0.91. That's a classification report. That classification report show the precision, recall, and F1 score. That's a confusion matrix. After that, I compare the performance of different machine learning models. We use the logistic and KNN and random forest and SVM for that project. I use for bar chart to visualize the accuracy of the other model. I mean logistic regression, KNN, and random forest and SVM. From that chart, we can clearly see the random forest has the highest accuracy while the KNN the lowest. That's a random forest model. Thank you.